Hello everyone, welcome back to the channel. Today we are starting session number 2 for determinant. Foundation work has been done. We have laid the foundation in our part 1, the session 1 of the chapter. Today we're going to complete our entire concepts along with 20 hand-picked questions which will make you exam ready. Yes, so we're going to solve 20 questions today. We'll practice 20 questions today. Again, I'll give you some homeworks also, but we'll practice those questions, and by the end of the session you will not just understand determinant, you'll also own the chapter. Let's begin with the session. I know your time is very important. Let's start. So as you know, in the planner what we have, part 1 is already covered. The foundation part was done. Okay, how to find determinant, 2 cross 2, 3 cross 3, all of that was done. Area of triangle, some questions we have done that as well, and based upon collinearity property also we have dealt with the question. Now in the part 2, today we're going to talk about minor, cofactors, inverse and adjoint, and also some questions on consistent form, right, like solving the linear equation and all. And the part 3 will come later, which will be on KCET PYQs, and part 4 will again come as JEE mains PYQs. Okay, so if you see the session outline today, what we're gonna do is going to start with minor and cofactors, understand the very basics of them, then move on to adjoint of matrix, deal with singular and non-singular matrix, basically define whether the inverse is defined or not, and then we go ahead, learn some important theorems, some properties and properties of adjoint and inverse of square matrix. As I said, working rule to find the inverse of matrix, I'll give you some 3 points straightforward. If you remember them, good enough to solve any question in the inverse. Consistent and inconsistent form, will also deal with that, and last we're going to solve some system of linear equations plus 20 questions. Okay, practice. Okay, total of 20 questions practice we're gonna do today. All right, you'll also have homework, so please don't forget. I can see very few students are giving me answers in the comment section, so even though all of you are present here, I'm telling you, please everyone, whether you find difficult or easy, give me an answer. Okay, even if you get wrong, you'll get to know what is the right answer, right? So very important to give me the correct answer, or any answer that you have after you have solved the question. Leave that in the comment section. Will that work? Let's start the session now. So you have seen this. Now first thing is going to be minors and cofactors. So before we move on to the cofactor, let's understand the minors first. So again, let's say we talk about 3 cross 3 square matrix. What happens there is, we'll have elements, right, present, a11, a12, a13, and so on till a33. Okay, that you know very well, right? Not a problem. Now in regard with any of the element, for example, if I talk about, let's say, a21, what happens? So if we talk about the minor of this particular element, yes, you heard me right. When we say minor, we always talk with respect to one of the elements. So let's say I'm talking about minor of the element a21, then what is it going to be, sir? It's going to be a matrix of order 1 less than the original matrix. For example, right now the matrix is of the order, 3 cross 3. This is the matrix right now. Okay, so when I say a21, basically what I mean is, so we'll have over here a11, a12, a13, right? A21 will be there, and over here also we'll have a22, a23, a31, a32 and a33, right? So when I say minor, what I mean here is basically remove the second, because I'm talking about minor with the element a21, right? So remove the second row and the first column. The remaining elements that you have, put it in the matrix. We'll have a12, a13, a32, and you can see a33 I have. If you find now the basically determinant value of this, got it? So first understand this. The original matrix is given to you. From there we are looking to find a minor of any of the element. Let's say the element is a21. What we do is we basically remove the row and column where the matrix is contained, and the remaining elements you put into the matrix. Find the determinant of that matrix. That's your minor. This is the minor of the matrix A2 of the element A21. M of the element A21, we represent it like this. Mi is A. So this is with regard to the element A21. So too much confusing, we don't have to do it all the time. Okay, just by looking at the element you can calculate it, but yeah, this is the understanding, this is the definition of the minor. how do we deal with it. Okay, so I hope you got it. Minor is basically the determinant of the matrix obtained after removal of row and column for the particular given element. Yes, for all the elements, right? For all the elements, let's say I have a total of 9 elements over here. I'll have to do the same method. There is no shortcut for this. To find minor, you have to do this way only. Got it? Now, next part is cofactors. How do you deal with that? So remember, I gave you guys a sign for all the elements. Remember, this was plus, minus, plus, and minus, plus, minus, plus, minus, plus. Based upon the sum, whether I plus j is even or odd, we had the sign of the positions. Got it? Remember a1 1, so 1 plus 1 is even, so plus. a1 2, the second element is 1 plus 2, so that is 3, odd, hence minus. a1 3, 1 plus 3 is 4, that is even, hence plus. Okay, so I gave you the sign convention for each of the element. Based upon the sign convention, you have to make the sign alteration in the minors. Basically, if I check here, if I write here mij, the minor of that particular element, for example in this case m21, tell me 2 plus 1 is odd or even? It is odd, sir, hence we have to put a minus sign over here, minus m21, and this becomes your capital A21, and this capital A21 is nothing but your cofactor. Understand this? Your cofactor is nothing but your capital A21, and how do you get that? In the minor, you see also the sign convention that is applied to that element. How do you find that? I plus j value, you're going to check whether it is odd or even. Odd means sign change. If the m21 value is negative, it will become positive. If m21 value is positive, it will become negative. Basically, sign change. If it is even, if I plus j value is even, if this I plus j value is even, no change in sign. No change in sign. Okay, but if it is odd, what will happen? Sign change. Sign change. Getting it right? So very simply understand this. If either you can remember I plus j part, even or odd, or you can simply remember this plus minus plus minus plus minus, because usually you're going to deal with 3 cross 3 matrix only. Okay, so but yeah, this is a basic understanding of this. I hope you get it. I plus j, even and odd. Okay, so for example in this particular case I have to write the general form. How I'm going to write it? So if I have mij over here, I'll multiply that with minus 1 power I plus j. How come, sir? I plus j will be even, it will become positive. It will be odd, it will become minus. Okay, so I'll have negative in that case. So this becomes your aij. This is the general formula of your cofactor. Aij, capital A, remember small a is for the elements of the matrix, whereas capital A is for the cofactors of each of the element. Again, as we had minus for each of the element, we'll have cofactors also for each of the element. All of you agree? Okay, so aij will be the cofactor written as minus 1 power I plus j times mij. What is mij? The minor of the element. Okay, so you got it right? So minus and cofactor must be clear. Let's see. So I have given everything in detail discussed over here only, but we'll see the slides also that I have made for you. Minus. In determinants of the order 3 cross 3, we get 9 minus corresponding to each of the elements. Okay, each of the 9 elements of the determinant. Minor of an element aij of a determinant of order n, which is more than 2, will become n minus 1. Remember, we had here the order is 3 cross 3, whereas this is what? 2 cross 2. So the order of the minor matrix, remember this also is a matrix, right? So not that minor value, I'm saying minor matrix that you get after removal of row and column will always be 1 less than the original given matrix to you. Okay, so over here if the matrix is given of the order n, this becomes the minor will be of the order n minus 1. Of course n has to be more than 2, right? N has to be more than 2, otherwise if the n value is 1, right, it will become n minus, so 1 minus 1 will become 0, right? Not defined. So basically n value has to be more than or equal to 2. In all those conditions, the minor will become what? The minor will become always n minus 1. Okay, and written only for square matrix. This is clear. Minor is clear. Now cofactor, again same thing. The minor mij multiplied with this particular sign minus 1 power I plus j gives you the cofactor value given like this. aij equals to minus 1 power I plus j mij. Even though we have many concepts to cover today, but I'm telling you one thing in advance only, they're not difficult, they're not challenging, okay? So if you are actually with me, if you leave a pen and paper right now, when I ask you to solve it, you solve it. Otherwise, do not worry, you'll get the class notes delivered to you in the WhatsApp channel. I hope you've joined it, right? If you have not joined yet, please join right now for the WhatsApp channel. Link will be given in the description of this particular video. Go ahead, check that out. Join the link, click on the link, join the channel, and the class notes will be given to you. You can practice and write things later. Right now, complete attention on the screen towards me, okay? Any other query you are having right now only, leave that in the comment section. Why right now, sir? It's not a live session, but it's recorded, but I watch your comments, right, later. So if you're leaving the comment, let's say when I'm doing this, you have a doubt at this point of time, don't wait for the video to end or later you're gonna ask, write the doubt at the same time, I'll get back to you, okay? So this is the cofactor all explained to you. Now there's a property, like how can you actually find determinant of a matrix using cofactors, okay? So what you do over here is, you multiply, whether first thing is you have to take one row or column, your choice, okay? Check here, 1 second. Yeah, check here, A11, A12, A13, okay? Sum of the products of the elements of any row or column. Very important. Pick your choice. There are 3 rows, 3 columns, right? Yes. Row 1, row 2, row 3, C1, C2, C3. You want to choose column 3, choose it. If you want to choose row 2, choose it. Any one you have to choose, okay? Any of the rows or column, only one, not one row, one column. Only one out of 6. We have total 6 options over here. 3 rows, 3 column. Pick any one of them, and for that particular row or column, you see all the elements. Let's say I have chosen my row 1. Let's say in this case I've taken row 1 only, no? So let's say I've taken row 1, or let's say I've taken row 3. I've taken row 3, okay? Then what happens is, what are the elements in my row 3? Remember, elements of row 3 is, sir, A31, A32, and A33, right? Elements of row 3 is A31, A32, and A33. Now what is you going to do, okay, to find the determinant of this matrix? Let's say this matrix is matrix X, okay? I want to find what? Determinant of the matrix X, so I'm going to write this as determinant of X. How do you find that? Basically, write the element A31, multiply this with the adjoint, the cofactor of the same element. There is a difference over here, sir. Small a31 and capital A31 has a difference. This part here represents element, whereas this represents what? Cofactor. Okay, so multiply element with respective cofactor and do it for all the terms with summation. So you're going to do A32, A32. Again, small a33, capital A33. Got it? Now if this sum of the product of the, I'm going to repeat myself, the sum of the product of element and cofactor, sum of what? Sum of the product. Product of what? The element or the cofactor of either of the rows or column gives me determinant of the matrix. Think about it. Check here. Check here. Sum and what? Product. Sum of the product of the elements with the respective cofactors, not others. Respective only. I cannot write here A21. If I write that, it will not work out, okay? I have to write the element with the respective only cofactor. When I do that and I take the sum across any of the row or column, my result is always determinant. If you do it otherwise, let's say I've taken here, row is A11, A12. This is my first row, right? A11, A12, A13 is my first row's element. But check cofactors, A21, A22, A23. A21, this is my second column, right? No, this is my second row. A21, A22, A23 is my second row. So I've taken different elements from a different row and I've taken cofactor from a different row again. Then what is the result going to be? 0. So if you take the respective rows element and its own cofactors, answer is the determinant. If you do otherwise, answer will become 0. In a determinant, the sum of the product of elements of any row or column with the cofactor of any other row. The word is very important. Other row. What happens? The result is 0. The result is 0. Got it? Might look silly to you, but I'm telling you, this can be asked in examination. Whether it's boards, MCQs can be asked on this, whether it is CET question can be asked on this, or whether it is JEE, even the properties based question can be asked on this. So please do not take this lightly. Very, very important concept. Okay, highly important concept. Got it? Can I move on now? Next. Okay. So next is find the minor and cofactor of all the elements in the determinant given like this. Okay, A, B, C, D. So we have AC, BD. We have 4 elements. We'll have 4 minus and 4 cofactors. Let's find M1 first. M11. For A, what is going to be this? Remove this and this. I get D. For C, what is going to be this case? For C, sorry, M12. I have to remove this and this, right? So I have minor as B. If I go for the second row, M21, I have to remove this and this, right? So I'll get C. For M22, I have to remove this and this, right? So I get A. I have understood, right? No? I'll explain again, don't worry. So here, one second. Yeah. So I'm talking about, let's say for the element D, which is M22, if I remove the second row and the second column, what is the left? A is left. That is my minor. Now what about cofactors, sir? What about cofactors? So sign, remember, this will be plus, this will be minus, this will be plus, this will be minus. Sorry, wrong. Minus plus. Excuse me, got a little cold. So plus minus, minus plus. Okay. So if you see my A11, my cofactor will be for the first one positive only, which is same as M11. So D, A12 again is odd, so minus M12, which is minus B. Please check, minus B. Okay, A21 is going to be minus, M21 going to be minus C, and A22, excuse me, A22 will become equal to M22, right? M22 equals to simply A. I wrote it as D. My mistake. Yeah. That's my cofactors. Have a look. Okay. As simple as that. In the case of 3x3 matrix, you have to find the determinant for the 2x2 matrix for each of the element. You have to do that. Okay. So that can be asked in your boards questions. Usually they are not asked to find all of these in your competitive examination, but in boards they can ask. In competitive examination they can ask you for 1 or 2 and give you options to choose from the given 4 options. So that can be asked. Concept can be asked, but not to find cofactors, basically the minus for the entire thing. Okay. Alright, let's go ahead. Question number 1 is done. Question number 2 now. Okay. Find the cofactors of the elements A12. See, that's how they can ask. For the elements A12, A22 and A32, they're asking the cofactors, not the minors, the cofactors. Let's find that. So for A12, right? So what is the smart way to do these questions? No, do not have to find all of this at one time. Start from the anyone. See, the word is written here, respectively, means the answer should be in that same order. Means this first option is for A12, this is for A22, this is for A32. Same goes for all the options. First part is 2 is A12, A22 and A32. So we'll check accordingly which is the correct choice. Okay. So A12 is where, sir? A12 is here. A12 is here. Okay. So for A12, I can remove this row and column. First row and second column I can remove. A12. Now what I get? I have my minus sine theta minus 1 and 1. This is my minor, right? This is my M12. Okay. Now M12 is, this means A12 will become minus of M12. Right? 1 plus 2 is odd. So minus of M12. Now find this value, minus of what? I am getting here minus sine theta. Okay, 1 into this is minus sine theta, and for this we'll get plus, right? Oh, this is going to be 0. Cancel. What is the answer? Simply minus 0. How much is that? 0. So my value is A12 equals to 0. Check this out. The cofactor is 0 for only one option like this. Option A is correct. For the first part, cofactor of the element A12, here is given as 2, here is given as minus 2 sine theta, here is given as 2, here is given as 0. My answer is coming as 0. I can just pick the option A, which is the right option. Got it? If it was not the case, if I had more option like this, then I have to go what? I have to go ahead and find A22 also, but not in our case. Okay, but please try and check. Find A22 and find A32. For all of you, as homework only, please find these two values. Okay, question number 2, let me know whether it is same or not. Let me know for question number 2, the cofactor A22 and cofactor A32 is coming same as 2 and minus 2 sin theta or not. Okay, you'll do that. Question number 2 is done. Question number 3, I think. Okay, find the sum of cofactors of all the elements. Sum of cofactor of all the elements. Okay, so for this, for the first element, what I get, 1 second. Now I can go faster right over here because it's not required for me to. So cofactor of A first element will be what? Minor will be 3. Okay, positive, so plus 3 only. A12, for this one what I have? 4, but my is odd, right? 1 plus 2, so I have a minus sign. A1 plus 2 is odd, so minus sign. A21, again minor is minus 2, but again minus sign because of what? 2 plus 1 is odd, so minus of minus 2, how much is that? 2. I told you sign change, not negative sign. Sign change, minus of minus 2. Okay, whatever the sign given to you, it will change, so it will become 2. Okay, next is going to be A22, minor will be 1, and 2 plus 2 is even, so remains as it is, no change. They are asking what? Sum of cofactors, add them. 3 plus 2 plus 1 minus 4. This is minus 4. Okay, so what I get? Please check. 3 plus 1 is 4. So this and this will cancel with this. I get answer is 2. Option number A is correct. Option number A is correct. Can be easily asked in your boards as a 1 marker in MCQs, or even can be asked in simple questions of KCET. Okay, when you see the KCET PYQs, you'll get to know the question can be of similar kind. That will come in the part 3 of this particular chapter. Question number 3 is done. Okay, next we start with adjoint of a square matrix. So far we have covered minor, cofactors, and we have done questions on them. 3 questions we have done. I hope you are able to get that. I have given you homework. Please cross check and let me know the answer. Okay, now adjoint of a square matrix. So I think you know this. This is the elements of a 3 cross 3 matrix. What is this? This is the respective cofactors, right or not? Capital A represents cofactors. So once you write this part, okay, once you write this part, so adjoint is basically adjoint of a matrix. Let's say A is nothing but it's a matrix. But how do you write it? Matrix of cofactors transpose. So basically you write this matrix, take transpose of this, that result is going to be your adjoint. I'll repeat myself. You find the matrix of cofactors, take transpose of the resulting matrix, that gives you adjoint of the matrix. Okay, check this out. So A11, A22, A33 remains as it is, except for that everything changes. A12 comes here, A21 goes there. A12 is here, A21, A31, A13, A32 and A23. So you have to take the transpose of your obtained cofactor matrix. Cofactor matrix, take the transpose, that's the result of your adjoint of the matrix A. As simple as that. Okay. Now, adjoint of the matrix A equal to ABCD is given as follows. Let's try to reach this conclusion. Let's find it out. How do we get that? So first thing is going to be what? Find the cofactor. Okay. So if I have to write the cofactors, I'll get A11. It'll be coming as simply D because it is even. A12 will be minus C. Actually, you know that very well. Going to be minus C, right? Because for A12 is over here, the minor is C. 1 plus 2 is odd, hence minus C. A21. What is A21? For this, you'll have B as the minor, but 2 plus 1 is odd, hence minus B. And last is going to be A22. This one, you'll have A, only A because 2 plus 2 is 4, which is even, so A is correct. Let's write that in the matrix. We have D minus C minus B and A. Okay. Now this is my what? Matrix of cofactors. I want to get what? Adjoint. Right, transpose to this. What I get? Please check. D and A will remain as it is. Minus C will come here. Minus B will come here. Now this is my adjoint of the matrix given to us, which is A. Cross check. DA minus B minus C. Yes or no? If you want to actually know a trick, I'll tell you over here. To find adjoint of a 2 cross 2 matrix, this is a trick for all of you. Trick for all of you. To find the adjoint of a 2 cross 2 matrix, don't do anything. Write here matrix first. AD, BC. Simply across the diagonal, interchange. Interchange. And across this element A and C, sign change. Excuse me. Sign change. Check this out. AD interchange means it will become DA, B will become minus B, this will become minus C, and that itself is your adjoint. Please check. D minus B minus C A. Okay. So no need to do all of this, no need to find any of the cofactor, nothing. Just one trick. For a 2 cross 2 matrix, adjoint is simply given as swapping the values across diagonals and changing the sign across your other elements. Okay. Got it? Non-diagonal elements has to be changed in the sign. Non-diagonal elements are changed in the sign, and diagonal elements interchanged. Okay, that's your result. Okay, let's move on now. All right. Now comes another thing before we start our major topic, which is inverse of a matrix. What is that this topic right now? Singular and non-singular matrices. Okay. Whenever you can find determinant of a square matrix, remember, square matrix, determinant is only defined for square matrix. So if the determinant is coming equal to 0, can happen, right? Think about it. 4 into 4 is 16, 16 into 1 is 16. Subtraction is going to be, the difference of them is going to be 0. Okay. It means determinant of A is coming equal to 0. This is called as singular matrix. As simple as that. Okay. Whenever you have determinant of a given matrix as 0, is called as singular matrix. But if you get determinant of a matrix, let's say over here we have B, which is not equal to 0, which is not equal to 0. For example, over here, check this out. 5 into 1 is 5, 3 into 2 is 6. So I get 5 minus 6. How much is that? Minus 1. Is it equal to 0? Of course not. This is called as simply non-singular, matrix. And your inverse of a matrix, is defined only for non-singular kind. Okay. If the matrix is singular kind, we cannot find inverse for it. Okay. But if it is non-singular kind, then only we can go ahead and find the inverse of that particular matrix. Okay. So this is clear. Okay. Next, some important theorems. Let's just go through it. Theorem number 1. If A is any given square matrix, then you write A adjoint A or adjoint A with A. Okay. Answer is always determinant of A times identity matrix of the same order. Determinant of A times identity matrix of the same order. You can see here IN. Okay. I is the identity matrix of the order N. A adjoint A or adjoint A times A is a multiplication, right? Adjoint A is what? Is the matrix of the same order formed of cofactors transpose. Cofactors transpose. I just showed you, right? Okay. Theorem number 2, what it says? If A and B are non-singular matrices of the same order, then A, B and B are also non-singular matrices. If A and B are non-singular of the same order, then even AB matrix means product of the A and B, or if you write B and A like this, you know there's a difference, right? AB and BA is not same in the case of matrices. Okay, we have learned that matrix multiplication is not always commutative. Okay. Remember we taught you, I taught you this in your session of matrix. Matrix multiplication is not always commutative. Matrix multiplication is not always or generally commutative. All of you agree? It means AB will not always be equal to BA. AB will not always be equal to BA. They are equal. I told you that time as well. In the case of inverse, they are equal, but not always. We'll see that later. But yeah, AB and BA will also be a non-singular matrix. Okay, will also be a non-singular matrix of the same order. Got it? Okay, moving on. Now theorem number 3, determinant of the product of matrices will be same as, basically you find the determinant of the product, or you find determinant and you find the product later. I'll repeat, whether you find determinant of the product of matrix or you find determinant of each of the matrix and then you take the product, result is same. Check here. First we did what? We did the product, then we applied a determinant. Or you did the determinant first for A and B individually and then apply the product, result is same. Okay, our square matrices of the same order. Let A be a non-singular matrix, yes. Adjoint of A determinant is given by determinant of A power n minus 1. There is actually a property over here. If you have, let's say, adjoint of adjoint, I'm writing it 3 times over here, adjoint of A. Can we do that, sir? Of course we can do that, right? Think about it. Adjoint of A is a matrix. Now that can also be found adjoint, right? We can find adjoint of a matrix A, all right? We can also find adjoint of the given matrix that you get after adjoint of A. Again, you can find one more time, okay? So if you have this and you're looking to find what? Determinant of this. You're looking to find what? Determinant of this, simply given by determinant of the matrix A. Very useful in the very useful in the examination point of view. Whether you see any of the examination, JEE, CET or your boards, extremely important topic. Okay, highly important. So what are you going to do? Determinant of A power n minus 1 power n minus, what is n, sir? N is the order. N is order. Power n minus 1, okay, power 3. Power 3. What is the power 3 over here? For 3 adjoints. 1, 2, 3. Based upon number of adjoints you have, same power will come over here as 3. Can you check that out? Okay. So determinant of A power n minus 1, power 3 in this case. How many adjoints over here? Only 1. That's why n minus 1 power, how much is there? Only 1. Getting the point? Okay. Highly important property. Please remember this. Next, what we have, some questions to solve. Minor of an element of a determinant order n more than 1 is determinant of order n minus 1, right? If the given matrix is of the order, matrix is given to the order n, right? 1 second. Matrix order is given to you is as n, then minors we just learned right now will be n minus 1, right? Option has to be C. Okay, option has to be option number C. Let's start. Question number 5 now. What it says, which of the following options is correct in a given determinant of A where A is given as Aij 3 cross 3, means it's a 3 cross 3 square matrix, of course. So which is the correct option? Please check. Order of a minor is more than order of determinant. No, not possible. Order of minor is less than order of determinant, right? 1 less actually. Minor of a element is always equal to, not always equal to. It depends upon whether the sum is odd or even. If it is odd, it will become negative of the minor or the cofactor, and if it is even, then it will become basically remaining that same in that case, but not always. Not always. Only in the case of even they will be same, otherwise in the case of odd, sign will be reversed. Cofactor of an element Aij is obtained by multiplying. Correct. This is right. This is correct. Option C is the right answer. Let's look at option D also. Value of the determinant is obtained by only multiplying element of row or column with corresponding. So you might get confused over here. So they are saying element with corresponding. They are saying that, sir, element and corresponding means they are saying that A11, A11, A12, A12, A13, A13. This is right only, no sir. They are saying only multiplying. Is it correct? You have to add them also, right? You have to add them also. That's why it is incorrect option. That's why it is incorrect. Getting my point? Option C is the only right option. Option A, B, D is wrong because this one is also wrong. You check here. Only multiplication is not true. You have to add them as well. Question number 5 is done. Let's move on. 6. Adjoint of the matrix A is what? This is the homework. Okay. Simple question, but give me your answers in the comment section. Adjoint of a matrix A will be which of the options? You have to give me. Question number 7 now. Question number 7. This is given as a singular matrix, then X is what? Given as a singular matrix, what is the meaning of singular matrix? Basically, if I take this to be matrix, let's say A, determinant of A will become equal to 0. Alright, determinant means what? Please check. 2 plus X if I am doing, I'll get 5 minus 2. Correct now? Mass 1 into mass 5 is 5 and 2 into 1 is 2. There's a subtraction over here. Next what we have? Next we have minus 3. I remove the second column and first row, I get minus 5 minus 2x. Minus 5 here and minus 2x. Alright. For 4 what we have? Plus 4. Please check for this element. 4 will have 1 and plus x. We'll have 1. 1 into 1 is 1 and mass x will become plus x after subtraction. This is your result. Please solve and give me the answer. This will be coming to equal to 0. Again homework. Okay. So I'm not giving you to solve everything. Just some help in the solution I want from all of you. So far we have given you, I think 2 or 3 homeworks I've given. 3 questions I've given as you as homework. Okay. So homework is there. Find this value and give me x is equals to what? Okay. This is your third question as homework. Give me answer in the comment section. This is your third homework. Okay, homework number 3. Please check. This is the second homework. And somewhere there I've given you first question also as the homework. Leave that in the comment section. Okay, question number 8 now. This is clear. You can do it. Yeah. If A equals to A 0 0 0 0 A 0 0 0, what is the answer for determinant of adjoint of A? We know that very well. Determinant of adjoint of A, excuse me 1 second, I made a mistake while writing. Okay, so adjoint of A is given by determinant of A power, order is 3, it means 3 minus 1 is 2, and how many adjoint we have? Adjoint is only 1, so we don't have to do anything over here, otherwise we have to do the power of 2 also. Remember? Power of n minus 1 we also used to do. Okay, so we have to keep it as 2 only because the order is 3, so 3 minus 1 becomes 2 and we have only one adjoint, so we have to do 2 power 1 which is same as 2. Determinant of 1 is the case over here. Matrix is given like this. Can you take A common? Let's do one thing. Take A common from the first one, we get A. From the second one again we get A. From the third row also we get A. What is left now? 1 0 0 0 1 0. Okay, and we have 0 0 1. Okay, basically we have A equals to A cube and matrix I, identity matrix of the order 3. What I want determinant of this, so we'll write here determinant of A will become what? Please check. It'll be A cube as it is outside. Okay, and we have over here determinant of I power 3, which is nothing but simply 1. How much is that? A cube. How much is that? A cube. Basically my value for determinant of A is A cube, hence my answer becomes A cube square. Answer is A power 6. Option number C is correct. Got it? Option number C is correct. Simple question. Okay, 9th one now. If P equals to 1 alpha 3 1 3 3 and 2 4 4 is the adjoint of 3 cross 3 matrix A. Okay, what are they saying? P is equals to adjoint of the matrix A. Okay, then and determinant of A is given as 4. Do one thing, apply determinant on both sides. What I get determinant of P equals to A power 2. Correct, right? We have been given P is the adjoint of A. We wrote that. We also have determinant of A value known. It means I have to use the property. So determinant of P will become determinant of A power 2 because order is 3 over here. So 3 minus 1 is 2. Okay. Now find determinant of P over here. From 1 what I get? From 1 I get 3 into 4 is 12. Minus 12, so that is gone. Please check. 3 into 4 and 4 into 3, that is gone. Next we have minus alpha. And for this we'll have 4 minus 6. 4 minus 6, please check. 4 into 1 is 4, 3 into 2 is 6, so that is minus 6. Okay, and we have plus 3. This and this is cancelled. I get 4 into 1, which is 4. And again we get 2 into 3, which is minus 6. Okay, this whole thing is equal to determinant of A square. How much is that? 4 square. Clear. right? 4 square is clear. Moving on, this is 0. We get over here minus alpha minus 2 and plus 3 times of minus 2 equals to 4 square is 16, right? 4 square is 16. What I get over here? 2 alpha minus 6 is 16. Bring this over here. I get 2 alpha is 22. Alpha is 11. Alpha is 11. Alpha is 11. Option A is correct. Alpha is 11. Option A is correct. Is it alpha or A? Alpha only, correct. Alpha is 11, option A is correct. Okay. Ninth is done. Simple enough. Ninth is simple, right? Simple. Now some properties of adjoint and inverse of a square matrix. So please check. If I have transpose over inverse, I can simply write inverse over transpose. First property is if I have transpose over inverse, I can simply write inverse over transpose. Can you do that? Of course. Second property, if I have adjoint of AB, I can write simply adjoint of B times adjoint of A. Adjoint of B times adjoint of A. Properties are very important. Please remember these properties. Okay. Adjoint of AB is adjoint of B times adjoint of A. Okay. Property number 3, if A is an invertible matrix, then adjoint of A transpose is simply adjoint of transpose of A. Okay, adjoint of transpose of A. Got it? This is the difference. Okay. Property number 4, if A is a non-singular square matrix, then adjoint of adjoint A becomes determinant of A power n minus 2 times A. Determinant of power A, determinant of A power n minus 2 times A. Okay. So let's move on. Some more properties to remember. I taught you this already. We have 2 adjoints over here, the power of n minus 1 is 2. If we have 3 adjoints over here, power of n minus 1 is 3. Taught you that very well, okay? No confusion. Property number 5 is discussed in detail. Property number 6 now, if A is a non-singular matrix, then determinant of inverse is same as inverse of determinant. It's very useful. I have taken a question on this, I'll show you, but it's very useful question. So properties I mean, determinant of inverse. So if you have to find determinant of inverse of a matrix, simply find the determinant first and then take inverse or reciprocal. Because determinant is a value, right? Power minus 1 becomes what? Reciprocal. Correct or not? Determinant is a value. Power minus 1 means reciprocal. Simple or not? Of course simple. Okay. Property number 7. If the product of 2 non-zero matrix is a zero matrix, then both of them must be singular matrix. Very important. Means for 2 non-zero matrix, when taken as product, you're getting the result as 0. You're getting the result as 0. It means the matrix individually should be singular in nature. Let's say I have A not equal to 0. I have B not equal to 0. Okay. But AB is equal to 0. A non-zero, B non-zero, but AB is 0. It means determinant of A has to be 0 and determinant of B has to be 0. Looks simple enough but useful in the properties. Remember, in JEE questions can be asked on this property. Very important. Okay. A non-zero, B non-zero, but AB will be equal to 0. When is the case? When we have singular matrix given for both of them. Okay. Yeah, both of them must be singular. Property number 8, adjoint of K is nothing but K power n minus 1 adjoint of A. K power n minus 1 adjoint of A. A is a non-singular matrix of order n, of course. Okay. Next we have inverse of matrix. Now the big trouble that we have, that questions comes in our boards also. The lengthy ones, high 6 marker, 5 mark question comes for our board, right? Those questions come from this topic only, inverse of matrix. Not directly, but they can also use questions on simultaneous equations, 3 equations of the linear algebra, x, y, z, make the matrix, find the inverse from there. So that concept, this particular concept plays the role to get 6 marks in the boards, again useful in your competitive examination as well. Okay. So remember, I told you this in the today's session couple of slides back, that we learned it very well in the session of the properties of matrix multiplication, that multiplication of matrix is not always commutative. But there also I told you is commutative only when the matrix are inverse of each other, right? When the matrix that is multiplied are inverse of each other, means when A is inverse of B or B is inverse of A, then AB equals to BA. What I said, if I have A as inverse of B or B is inverse of A, then I can write A into B will be equal to B into A, because both the cases will be equal to simply identity matrix. We have learned that, remember, A times of A inverse is what, dear? I. And I can replace this A inverse by what? B. Yes or no? If my A inverse value is B, I can replace B as A inverse, okay? B as A inverse, it means AB will become equal to I. We have learned the property. All of us know the property, right? A times of A inverse is I. Then I can replace A inverse with B. I get AB equals to I. Same I can apply for BA also. That also will be I. So only when the given two matrix in product are inverse of each other, I can have the property that AB equals to BA, which is both equal to I. Got it? Okay. So we have B is called inverse of the matrix A and is denoted by A inverse. Denoted by A inverse. All right. The theorem is okay. Now we are looking to find whether it is possible to find A inverse or not. For that case, first thing is going to be what? First thing is going to be finding your non-singular case. Non-singular case. Okay. This is the proof of this condition. AB is given equal to I. We find the determinant on both sides. You know, we can split the determinant like this. Remember, determinant of A, determinant of B. If you move on this side, it becomes what? B inverse. Remember? Okay. All right. So A is a non-singular matrix. Conversely, please check. So basically, yeah, A square matrix A is invertible. They have given that is invertible, and they are asking you to prove what? If it is non-singular, we got the result as non-singular. Non-singular means non-zero. Because if this was 0, can you multiply 0 to anything to get 1? So basically, we took it as invertible, and we are trying to prove it is non-singular. Okay. If A was 0, basically a singular matrix, what I have? I'll have determinant of A equal to 0. If you take 0 over here, can it be ever multiplied to any number to give the result as 1? Never. It means it has to be non-singular matrix. Got it? Converse is also there. Okay, what is in this case? We have A adjoint A and adjoint A with A equals to determinant of A times I. Theorem number 1. Theorem number 1. What you do in this case, simply divide both side or all this side by determinant of A. Here you divide, here also you divide, and here you're going to be cancelled. What happens? Please check. I have A times of 1 by determinant of A adjoint A, 1 by determinant of A adjoint A. This becomes your inverse. This becomes your inverse. Please check. This becomes your inverse. So inverse formula is nothing but adjoint of A by determinant of A. Please check. If A into this value, it means this has to be B, let's say, right? Equals to I. It means this B and A has to be inverse of each other. Correct, na? If I take to be, let's say, adjoint of A by determinant of A, I take it as a matrix B. I can do that. I can do it. Okay. When I do that, I get what? AB is I. Only possible if I have A inverse. Correct. It means B is nothing but A inverse. It means A inverse formula is adjoint of A by determinant of A. Okay. I'll remove some markings to make things simpler for all of you. Okay. Let's erase these things. All right. Okay. So I think now it's clear. Things are clear now. Okay. So very important to understand how we get the formula of A inverse. Okay. Theorem was to prove it is non-singular, and converse is to get the formula of A inverse. Got it? This is very important to all of you, how to find the formula of, how to find A inverse, adjoint of A by determinant of A. Okay. That's the outcome that you have to remember from this particular converse theorem. Okay. The properties of inverse of a matrix, some properties. Inverse of inverse is going to be the matrix itself. Of course, inverse of inverse will be cancelled along the effect of given to you. AB inverse is nothing but B inverse A inverse. If you have two matrix and looking to find the inverse of that, what is going to be the case? Simply find the inverse of the second matrix and then multiply with the inverse of first matrix. It reverses the order. Please check over here also. If you have ABC, reversal law will apply over here also. CBA. Remember, ABC, CBA. So first you're going to find inverse of C, then inverse of B and A, and multiply in that order. First C inverse, to B inverse, A inverse. Okay, C inverse, B inverse, A inverse. Okay, and we have K A inverse. Simply it become 1 by K because K is a constant. It will be K inverse means reciprocal, and we have A inverse as it is. K is a non-zero value because otherwise it will be undefined, right? 1 by 0 will be undefined. So not the case. We can't take it over here. Next is what? A inverse or A inverse A is equal to I. Already explained you right now. Okay, only square matrix have adjoint and inverse. That's very much clear to us. If A, B, C are invertible matrices of the same order, then A, B, C can be written in this form also, like this. Okay. Okay, working rules to find. Now this is basically, sir, you taught me everything, concept is known. Now give me simple points so that if a question comes, how do I find inverse? How do I find inverse? For that question, this is the answer. This side is the answer. Working rules to find the inverse of matrix by using formula. Okay, not shortcut, not trick, formula only. Okay. Let A be the given matrix, then first find. I've also given you, I think, trick in one of the shorts. You can go ahead and check that out on our platform. You'll find in shorts category there's a trick, okay, where I've taught you how to solve these matrices faster. Okay, so let's see. Let A be the given matrix, then first find determinant A. First step is to find determinant A and check whether it is 0 or not. If 0, we can simply say that inverse does not exist. Inverse does not exist. If determinant of A is 0 means inverse does not exist. Okay, but if it is non-zero, my first step is to say remain same. First step is to find the determinant of the given matrix. If it is non-zero, then you're going to do what? Find adjoint of A. Find adjoint of A. How do you find adjoint of A? Find the cofactors, remember, and from there you take the transpose of that to get adjoint of A and divide that by the determinant of A. That's your inverse. Okay, that's your inverse. Check. That's your answer. 3 steps, simple ones. Now let's solve this question. Okay, so what I'm saying, if A equal to 1 minus 2 3 0 minus 1 4 minus 2 2 1, then find A dash transpose, A dash inverse. Let's find A dash first. Let's find A dash first. What is A dash, sir? I'll keep diagonal as it is, so minus 1 and 1. Transpose means minus 2 will come here, 3 will come here, 0 and minus 2. Okay, and over here we'll have 4, we'll have 2. We'll have 4 and 2. I've taken the transpose, right? I've taken transpose. Now I have to find out inverse of that. How do you find inverse? First step is to find determinant and check non-singular there or not. Determinant you find across 1. So what I'll have? Minus 1 minus 8 actually. Minus 1 minus 8. Excuse me. Yeah. Please check. 1 into minus 1 is minus 1. 4 into 2 is 8. Across 0 everything is gone. So I have to just simply write minus 0. And lastly minus 2 because element is minus 2. For this I get minus 8 and plus 3. Minus 8 and plus 3. Okay. Got it, right? Minus 8 and plus 3. What we have over here is minus 9. And over here we have minus 2 times of minus 5, right? And I get minus 9 plus 10. How much is that? Plus 1, right? Correct, no? This is correct. Minus 1 minus 8, that is minus 9. Okay, and this is going to be minus 8 plus 3, which is minus 5 into minus 2 is plus 10. Determinant of A dash is coming equal to simply 1. Okay, I might have made a mistake in calculation, so please cross check. Our next step is to do what? Determinant is found out. It is not equal to 0. Means non-singular, so your inverse exists. How do you find inverse? We need to find the, so inverse formula we know very simple, adjoint of A dash by determinant of A dash. Determinant of A dash. Okay, it's not A inverse, it is A dash inverse, right? There's a difference. The question is changed. Okay, A dash inverse, please check. A dash inverse. Okay, now how to find adjoint of A dash? So for that we have a trick. Please check adjoint of A dash. For that you're going to write the matrix A dash once again, 1 0 and minus 2. Let me just write it there. I'll tell you. Minus 2 minus 1 2 3 4 and 1. Okay, so this is all to find what? To find the adjoint. What are you going to do? Write the first 2 rows again. So 1 0 and minus 2. Over here also minus 2 minus 1 and 2. So row 1 and row 2 is written again. And what is the next step? To write the column 1 and column 2 again. What I get? 1 minus 2 3. Okay, 1 minus 2 and 3. And 1 minus 2. Again we have 0 minus 1 4 0 minus 1. Now we get 5 cross 5 matrix. Now we get 5 cross 5 matrix. Next step is very simple. Eliminate the first row of 5 cross 5 and first column of 5 cross 5. Remaining elements that you have, go in the column wise, okay, of 2 cross 2 matrix. Find this product of cross multiplication and write in the row. I'll show you. So simply write here adjoint of A dash equals to, make a matrix, check this out. Minus 1 into 1 is minus 1, 4 into 2 is 8. Answer becomes minus 9. That's my first element of adjoint of the matrix A dash, not the cofactor. Simply directly I'm getting adjoint, okay? Next what we have, go in the column over here, the vertical, and write in the row. 4 into minus 2 is how much? Minus 8. 0 into 1 is how much? 0. So I get answer here as minus 8. 0 into 2 is 0. Minus 2 into minus 1 is going to be simply 2. Subtraction will make minus 2. There's a subtraction, right? 0 into 2 is 0, minus of this multiplication. So 2, difference will make again minus 2. Answer is minus. This is my first row of the adjoint of A dash. Same way I'm going to do from here. Have a look. From here. 6 plus 2. How much is that? 8. 6 plus 2 is 8. Okay. And we have 1 minus, so plus 6. We have minus 2 over here. So 1 plus 6 will become 7. 4 and minus 2 becomes simply 2. Please check. 2 into 2 is 4. This is a minus sign gets out. 2 into 1 is 2. Difference is 2. Again, this is done. Let's do the last one. 2 and minus 2 into 4 is minus 8. And we have 3 into minus 1. How much is that? Minus 3 becomes plus. So minus 8 plus 3 is minus 5. Okay. And we have 3 into 0 is 0. And 4 into 1 is simply 4. So minus 4. Minus 1 and 0. So simply minus 1. If you're not sure about this calculation, do one thing, pause the video, do it on yourself and check the calculation from my side, whether it is right or not. If it is wrong, let me know that in the comment section that I have made a mistake in the adjoint of A dash. Now, what are they asking us? They're asking us to find, please check, they're asking us to find A dash inverse. How much is that? Adjoint of A dash by determinant of A. Determinant of A is how much? Simply equal to 1. So it means what? My A dash inverse will be equal to adjoint of A dash, because this is going to be 1. How much is that? Same value. Please check. This is my answer. This whole thing is my final answer actually, because determinant is equal to 1. Hence, the adjoint itself becomes the inverse. Got it? Have a look. 10th one is done. Question number 10 is done. This is your answer. This whole thing is your answer. That's your inverse. Okay. Let's move on. Clear? Okay. Next, question number 11. If A equal to 3, 2, 1, 1, then find the values of A and B, the variables A and B, respectively, such that a condition is given like this: A square, A, capital A, small a, and B, I. Okay. So I'll give you the hint. It's a homework. So first find A square. It's not a question from determinants, from matrices actually, but I wanted to give you over here. So how are you going to do that? So multiply these two. Okay. And then find A alpha, or simply A small a. For that you'll have 3A, 2A, A plus A, and the last one is BI. So BI will become what? BI will become B 0, 0B. Subtract and get the values of A and B. Okay. Let me know what is the answer. I think should come as option A. I think, I'm not sure. Solve it. Okay. It's a homework. I think fourth question is homework today. Fourth question. So A square to find the multiplication. Okay, from here 3, 2, 1, 1. You can do that, right? 3, 2, 1, 1. I've taught you all of this. Please solve it and give me the answer in the comment section. Fourth homework. Give me answer in the comment section. Comment your answer. Got it? So 11th one, solve it and give it to me. I think option should be either A or B. I'm not sure, but A or B. I think A should be the right answer. Cross check. Okay. I think that it is A, but not sure. I have to solve it to get it. Okay. Solve it and compare is going to be very, very easy to solve it. Okay. Question number 11th is done. Question number 12 now. The matrices A equals to 1, 1, 2, 1, 3, 4, and like that. B is adjoint of A. C is 3A. They're asking us the value of adjoint of B, determinant, upon C, determinant of C. Okay. Adjoint of B, right? So B is nothing but adjoint of A. So basically I have adjoint of, okay, by C. What is C? 3A. Correct? I've put the values of B and C. B is adjoint of A, so adjoint of A, and C is 3A, so 3A. We have the properties. Cross check. So adjoint of A becomes simply determinant of A power the order minus 1. What is order here? 3 cross 3 means 3 minus 1, so 2, and number of adjoints, that is the power. So we have 2 adjoints over here, so 2 power 2, and 3A becomes what? 3 cube determinant of A. 3 cube determinant of A, right? K power n, remember the property is K power n. K is the constant and n is the order, so n is what over here? 3. Okay, so what I get now? I get here A power 4 divided by 3 cube, and determinant of A cancels, so my final thing is becoming what? My final thing what we are looking for is determinant of A power 3 upon 3 power 3. Okay, we'll see that later. Let's find determinant first. Determinant of A we have to find. So for 1, what I'm getting? 9 minus, so 9 plus 4 actually, correct? 3 into 3 is 9, minus 4 becomes plus 4 with subtraction. We have next term as minus 1, gets cancelled. Second column, first row, 3 minus 4 we have. 3 into 1 and minus 4 we have, with plus 2 what I'm getting? Plus 2 I'm getting minus 1 and minus 3. Let's cross check. I'm getting here first term as 13. This is minus 1, right? So it becomes plus 1, 14, and we have minus 4 into 2. So it becomes minus 8. What I get? 14 minus 8 is 6. 14 minus 8 is 6. Okay. That's the determinant of A value. Please cross check. I want to find this value, right? So determinant means 6 power 3. Sorry, not 6 determinant. Determinant of A value is 6. So 6 power 3. Divided by 3 power 3, how much is that? 6 by 3 power 3, how much is that? 2 power 3, how much is that? 8. Option C is correct. Question number 12, option C is correct. Have a look. Okay, simple enough. Question number 12, option C is correct. 3 by 3 is 2, 2 cube is 8. Let's move on. Question number 13. Okay, so what are they asking? Find determinant of B for 2 cross 2 matrix such that, okay, alright, so let's do one thing. Take this as matrix A. Take this as matrix A. Okay, sorry, not determinant, matrix A. Excuse me, 1 second. Matrix A times B equals to this matrix C. Okay, I've taken this as matrix number C. A, B, C is given. Now we want determinant of B, right? How do you do that? Apply here the property of determinant. A, B equals determinant of C. Taking determinant on both sides. I can do that. Okay, determinant of AB should be equal to determinant of C. Okay, what I get from here? Determinant of A, determinant of B should be equal to determinant of C. Alright, so what I get from here? Determinant of B equal to determinant of C upon determinant of A. Determinant of A. Let's find determinant of A first. Determinant of A is how much? 7 2s are 14 minus 5 is 15, which is minus 15. Answer is going to be 29. That's the determinant of A. Okay, now next step is to find determinant of C. Okay, so let's do it over here. We get 17 into minus 13, so minus 9. 13 7 is 91, so 1. 13 1 is 13 plus 9 is 22, so minus 22, minus 2 to 1, minus 221, and plus 47. Correct? Minus 47, there is subtraction over here, so plus 47, difference you check. 11 minus 7 is 4, again 11 minus 4 is 7, and 1 minus 174 is the determinant C value. I'm looking for determinant of B, put these over here. What I get? Determinant of B equals to minus 174 divided by 29. 9 6 are 54, right? 9 6 are 54 carries 5, and 5 to the 10, sorry. 6 to the 12 plus 5, 17, correct. 6 is the answer. Sorry, minus 6 is the answer. Have a look. Option D. Minus 6 is the right answer. 13th is done. Question number 13 is over. Question number 14 now. Before that, we have to complete one last topic in this chapter, which is consistent and inconsistent systems. So whenever you have that system of equation has one or more, even infinite case is true, then that happens is we call the system to be consistent form. We call the system of equations to be consistent form. And whenever you have no solution existing in nature, when you have if its solution does not exist, no solution basically, that is called as inconsistent form. Inconsistent form. Okay. Now check this out. So if you have three equations given like this, linear equations, a1x, b1y, and c1z, so on. The constant is given as d1, d2, d3. Okay, and this is the coefficients a1, b1, c1. Then to find it, you have to again use the linear method also. You can solve that away, but you can also use the inverse of a matrix method and get the result. Okay, for that what you're going to do, make a matrix of the coefficients first. Check here, a1, b1, c1, a2, b2, c2, so on. You're going to make it over here. Going to be a 3 cross 3 matrix. XYZ will be your what? XYZ will be your variable matrix, which will be a 3 cross 1 matrix, column matrix. Okay, and then again you'll get another column matrix 3 cross 1. The property will be simply, first matrix is called as the matrix A, this is called as the matrix X, and this is the matrix B. The property is very simple, AX equals to B. AX equals to B. You want to find the value of XYZ, right? So to find XYZ, you're going to do what? Multiply A inverse A, X as it is, and A inverse B. Okay, so this will become I. Can I ignore that? X equals to A inverse B. To find X value, simply find inverse of A and then multiply that with B. Inverse of A, multiply that with B. How do you find inverse of A? Taught you that already. Find the adjoint first. How do you find inverse? Find the adjoint first, divide by determinant. But before that, check determinant is equal to non-zero value. If it is 0 means it cannot be, inverse cannot exist. Okay, so please check whether determinant is coming as non-zero or not. This should be a non-zero value, should be a non-singular matrix. From that you can find the adjoint first. How do you find adjoint? Also given you tricks, shortcut for 2 cross 2, 3 cross 3 matrix, use that to find the adjoint. Divide by the determinant itself to get the result of inverse. Use the inverse multiplication with B to get the value of X. Okay, so this is a system of equations, so questions to be solved this method. Now we can have two cases over here. The case 1, as I said, if it is non-zero, inverse exists, and you can operate it like this to get X equals to A inverse. Already explained you this part as well over here. Okay, as inverse of matrix is unique, so the system of equation will be consistent with unique solution, for the given set of variables. Okay, only when the case is A non-zero, when the determinant is non-zero. Okay, all right, this is also called as matrix method to find the solution of a system of equations. Case 2, when it is 0, basically it is a singular matrix. When the determinant is coming equal to 0, it's a singular matrix. Then you'll have two subcases, subcase 1, subcase 2. If the adjoint of A and B is non-zero, product of adjoint of A and B is non-zero, then what happens is, simply we call this to be inconsistent. I repeat myself, if adjoint of A product with B, the matrix B, is non-zero, then system is inconsistent. But if adjoint of A with B is 0, then it can be either inconsistent or consistent. Basically it means it can have either infinite solution, or it can have no solution, Basically it can be either consistent or inconsistent, not unique wala case. Okay, remember in the consistent we also had unique case. This is the unique solution case. This also is consistent form. But for this case you must have determinant to be non-zero. But if the determinant is 0 and you're getting adjoint of A times B is also equal to 0, it means what? It can be both. Either of them it can be possible. Either inconsistent or consistent. But which type of consistent? Infinite many solution type of consistent. Okay, so this completes your concept part. Let's solve some questions. So I'm going to solve this question using matrix method. Solve the following system of equations. So I'm going to solve the first part. This is your homework. I think this is your 5th homework today. Okay, total of 5th homework today. Okay, let's solve this. I have to solve this equation. So what I have, let's make the matrix first. 1, 2, the coefficients 1, 2. Second one 2, 3, 2, 3. The variable matrix, the column 1, x, y, okay, and the constant which is 2 and 3. This is A, this is X, this is B. I want to find X, it means I have to find A inverse B. How do you find A inverse first? First find determinant of A. First find determinant of A. Check this out. 3 into 1, 2 into 2. So 3 minus 4, how much is that? Minus 1, which is not equal to 0. Which is not equal to 0 means non-singular. Inverse exists. Okay. How do you find inverse? Adjoint of A. We have to find out first. How do you find adjoint of 2 cross 2 matrix? Very simple. Reciprocate this. Swap this value. 3 here, 1 here, and change the sign of 2 and 2. Both are negative, so minus 2. Okay, minus 2, minus 2. That's my adjoint. What is my inverse going to be? Inverse of A will become, have a look, adjoint A by determinant of A. Sign, we have minus 1 over here, right? Dividing all these elements by minus 1 will make sign reversal. Do that. This will become minus 3, plus 2, and minus 1. Sign reversal for each of the element because of the determinant value is minus 1. Okay. Now I get A inverse also. I want to find X value. Please check. We have minus 3, 2, 2 minus 1 multiplied with the constant B, 2, 3. Let's do that. Minus 3 into 2 is how much? Minus 6. 2 into 3 is what? Plus 6. Correct? Minus 3 into 2 and 2 into 3. First element is done. Next we have 2 into 2, which is 4. Minus 1 into 3 is simply minus 3. Correct? Please check. Minus 6 plus 4 minus 3. My answer is coming as 0 and 1. So this is my value for matrix X. It means my X value is 0 and my Y value is 1. Answer is done. Okay. Same way, please use the same approach to find the second questions inverse values. Okay, and then check for the X and Y values. Same approach. This is homework number 5. Okay. I'll have one more homework to give to all of you. That will be last of it. Total of 6 questions I've given. So not all of them are actual homeworks. Actually, I've done some part and asked you to do it. Okay, but yeah, I want 6 answers from all of you. This is the question number 5 as homework. Question number 6 also will be there. Now, if you might be confused at where to get this homework, sir, don't worry. Class notes is available. Join the WhatsApp channel, download the class notes, and basically check from here wherever I've marked homework for that question. Give me the answer in the comment section. Okay, 14th is done. 15th now. Let x equals to x1, x2, x3. Okay, same. X is given, A is given, B is given. So you're going to want to find what? You're going to find x value. You have to do A inverse B for finding A inverse. And to find the determinant of A should be coming as non-zero value. Please cross check. This is your homework number 6. Homework number 6. The last homework for the Pakka. Last homework, okay? Determinant of A is non-zero. Find that value. From there you can find adjoint. How do you find adjoint? Remember, write the matrix first, write the first 2 rows, then first 2 columns, the trick I gave you for adjoint. So use the trick. For adjoint of A, use trick. Okay? Use the trick that I've given you in the session today itself, and that you're going to use adjoint of A to find inverse as same thing, adjoint A by determinant of A. Yes, and then you're going to multiply this value with B, right? Over here. Once you get A inverse, multiply that with B to get the value of X as one of the answers, option A, B, C, D. Let me know that as well. Okay. Question number 15 is done. Homework, total I've given you 6 homeworks. Please solve it and give me the answers in the comment section. I want that. Otherwise, I'll stop giving you homeworks only. All of you watching the sessions, please give me the homeworks answers in the comment section. I'm very serious about this. Okay. Question number 16 now. If A is 2 minus 3, 3, 4, then find the A inverse. Find the A inverse. First step is to find determinant. Okay, so what I get, 8 minus of minus 9, how much is that? 8 plus 9, how much is that? 17. How do you find inverse of this? Very simple. Adjoint of A should be equal to what? Just take 4 over there, 2 over here, correct? Solve the values across diagonal. So solve the value across diagonal means 4 comes here, 2 comes here. Sign change. So this will be plus 3 and this will be minus 3. Sign change. Okay, not values interchange, only sign change. Okay, you want value of what? Inverse. Right here, 1 by 17, 4, 3, minus 3, 2. 4, 3, minus 3, 2. Option A is such. Option B is correct. Option B is correct. Please check. 4, 3, minus 3, 2. Option B is correct. Yeah. Yes. 16 is done. Question number 17 now. Okay. A is given, B is given. Find the value of AB inverse. Find the value of AB inverse. Okay. How do you solve it? AB inverse is given by what? Is given by B inverse A inverse, B inverse, A inverse. Let's find A inverse and B inverse separately and multiply them. What I get for this, please check. My B inverse will be what? My B inverse value is how much? For that I have to find the determinant first. Determinant is how much? Minus, so we get 3 over here and minus 2. Correct now? 3 into 1 is 3 and minus 1 into minus 2 is simply 2. There's a difference, subtraction is there, so 3 minus 2 I get for determinant. And for adjoint what we have? 3, 1, 3, 1 and sign change, so 2 and 1. That's my adjoint, right? So I get the value as 3 minus 2 is how much? 1. So B inverse is 3, 2, 1, 1. That's my B inverse. Let's find A inverse now. For that we will find the determinant first. Please check. Determinant will become minus 8, minus 3, so minus 11. Cross check here. Minus 8 and minus 3. So minus 11 is my determinant value. And what about adjoint? Interchange the values in the numerator. Sorry, in the numerator of adjoint. Minus 4 will go over here. 2 comes over here. Sign change means minus 3 and minus 1. Okay. Now what I want to do? I want to multiply these values to get the result. So I have to write this as B inverse, A inverse. This is a constant number minus 11. I'll keep it outside as minus 1 by 11. Multiply now. First B inverse. Where is that? 3, 2, 1, 1. Next is what? A inverse. Minus 4 minus 3. Excuse me. Minus 3 and minus 1 and 2. Minus 1 by 11. Multiplication 3 by 2. Row to column. Minus 12. Minus 12 and minus 2. So minus 14. Correct? 3 into 4 is minus 12 and we have 2 into minus 1 again as minus 2, so becomes minus 14. Again first row second column, so minus 9 plus 2, so minus 7, right? Minus 9 plus 2 is minus 7, okay? 3 into 3 is minus 9 and 2 into 2 is 4, sorry, so minus 5, no? My bad. 3 into 3 is minus 9, 2 into 2 is 4. I add them. Minus 9 plus 4 is minus 5. And next what we have? 1 into minus 4 is minus 4 and minus 1 becomes minus 5. And we have minus 3 plus 2 becomes minus 1. Sign change because of this minus sign outside. 1 by 11 is as it is. 14, 5, 5 and 1. This is my value for AB the inverse. Okay, 14, 5, 5, 1. 14, 5, 5, 1. Option is only A. 14, 5, 5, 1. Outside we have 1 by 11. 14, 5, 5, 1. And outside we have 1 by 11. 17th question is also over. Question number 18th now. Okay. If B equals to 5, 2 alpha, 1, 0, 2, 1, alpha, 3 minus 1 is the inverse of a 3 cross 3 matrix. Okay. So B is inverse of A. They are also saying this, determinant of A plus 1 equal to 0. It means determinant of A equals to minus 1. Determinant of A equals to minus 1. Okay. They're saying B is inverse of minus A, right? Apply determinant on both sides. We get B determinant equals to A inverse determinant. We have the property, remember? A determinant the inverse. We have learned the property today only. If you have to find determinant of A inverse, simply find determinant first, then take reciprocal. So from here what I get? I get determinant of A is how much? Minus 1. So minus 1, the power, minus 1 is how much? Simply 1 by minus 1. How much is that? Minus 1. What I'm getting now? I'm getting determinant of B is equal to minus 1. Please check. I hope this part is clear to all of you. Right? Okay. Now determinant of B can be found, of course, across column 1 we can use, because there's a 0 over there. So 5 if you take, determinant of B is coming here as 5 if you take, minus 2 minus 3, minus 2 minus 3, with 0 everything is gone, plus alpha, what we will have? 2 alpha minus 2, 2 alpha minus 2, got it? I'm getting this value as minus 1 equals to minus 25, right? Minus 2 minus 3 is minus 5, so minus 25. And we have over here 2 alpha square minus 2 alpha. Bring this 1 on this side, minus 1 on this side becomes plus 1. I get 0 equals to 2 alpha square minus 2 alpha minus 24. Correct, right? Minus 1 comes over here, becomes plus 1. Minus 25 plus 1 is 24 in negative sign. Take 2 common, I get alpha square minus alpha minus 12. 0 over here, bring this 2 on this side, simply 0. So I get 0 equals to alpha square minus alpha minus 12. Factors over here. Okay, very simple. Alpha minus 4 and alpha plus 3. Please check. Please check. Minus 4 into 3 is minus 12. Minus 4 alpha and 3 alpha will become minus alpha, and alpha into alpha is alpha square. Okay. From here I am getting the factors values. From here alpha is coming as 4 and alpha is coming as minus 3. What are they asking us? Sum of the values of alpha. Sum of the values of alpha. Okay. Please check, add them. So you get 4 plus minus 3. How much is the answer? 1. Basically what are they asking? Sigma alpha. Sum of all the alphas will be 4 minus 3. How much is that? 1. Option B is correct. Very easy and interesting question. Good question, okay? Question number 18, option B is correct. Answer is 1. If I have done any mistake in the calculation, let me know in the in the comment section. I might have made a mistake, but I've tried not to. 18th question number, answer is B. Clear? 19th one now. Last 2 questions. If A is, excuse me, there's a mark over here. If A value is given like this, a matrix of 3 cross 3 order, what are they asking? Correct option. Please check. Inverse exists or not. For that, what we have to do? Simply find determinant. Check for the singularity. What I get? Again, we find across the third column. There are 0, 0, 0. That's why. So you get what? 1 times of sec square theta. Second to sec is sec square minus tan square. 1. This is nothing but identity. Sec square minus tan square is nothing but 1. Trigonometric identity, right? Remember, grade 10. 1 plus tan square is sec square. So sec square minus tan square is 1. So I'm getting determinant of 1. Sorry, A value is equal to 1, which is non-zero. It means A inverse exists. A inverse exists. Option is A. Option is A. Option is A. Okay. The last question of the day. All right. If this is given like this, find the value of x and y. Okay. Let's do that. Multiply this. X times of 1 is x. Y times of 1 is y. Equal to 2. Same way. Minus 1 times of x is minus x. 1 times of y is plus y. Equal to 4. Add them. Cancel. Y plus y is 2y. 2 plus 4 is 6. Y value is 3. Y value is 3. Once y value is 3 means x has to be minus 1. How come, sir? Because you have to add them to get 2, right? Add these two. 3 plus minus 2. How much is that? 2 only. So x is minus 1, y is 3. X is minus 1, y is 3. Option D is correct. Option D is correct. Option D is correct. Okay? Got it? This is clear. Question number 20, option D is correct. Minus 1, 3. Any other mistake I have made in the calculation, you're going to let me know. And this is it for the session today. Yes, we have solved 20 questions. I have given you 6 homeworks. Not 6 questions as homework. I have given you 6 homeworks where I want answers from all of you. I have marked it in the questions HW 1, 2, 3, 4 till 6. What you can do is simply download the class notes and give me the answers in the comment section. Otherwise, you can watch the video and give me the answers as well. But I want the answer very seriously from all of you. Okay, so this is it for the session today. I hope you had fun. We have completed our entire portions of determinant. Next comes your CET PYQs and JEE Mains PYQs. With this, so I think now you're getting the concept very easily. With this, I can end the session today. I'll see you again very soon. Till then, take care of yourself. Bye-bye.